Good morning. I want to thank you for giving us this opportunity to tell you about the success that we have had implementing BIM and VDC on 25 university projects over the past 5 years. These projects have been both new construction and building renovations. They have been on projects of many sizes and scopes, and they all have been successful in providing the university with higher quality construction at reduced costs, all while meeting or beating schedules. We have furthered this success using BIM for facility operations. Eric and Craig will talk more about this later. Today I'm going to talk about how we implemented BIM and how we procure BIM in design and construction. I will finish up by telling you how you can learn from our experiences and advance your learning curve by building upon our success. The Pennsylvania State University is one of the largest public universities in the U.S. with almost 100,000 students. We have 21 campuses throughout the state of Pennsylvania with over 1,700 buildings comprising almost 29 million square feet of floor space. That's about 2.7 million square meters. Our largest campus is at University Park in the center of the state, where over half of our facilities are located. Over the last 5 years, the university has spent about $2 billion on capital projects. About 70% of this was on new construction and 30% on renewals and renovations. We have recently embarked upon another $2 billion 5-year capital plan that focuses primarily on capital renewal and renovations. We have had tremendous growth over the last 5 years, and BIM and VDC were responsible for helping us to successfully deliver these projects. We anticipate even greater success over the next 5 years as we implement the same processes on existing facilities. While we initially implemented BIM for the successes reported in design and construction, we soon realized that the biggest win for us was a better way to manage all of the information generated during the construction process and leveraging that to better manage our buildings. The attention to detail of the BIM information processes has resulted in efficiency gains in many areas of our operations. By better managing our information, we can better manage the risk associated with building projects, thus delivering projects within costs, with difficult schedules, and with better quality. The Office of Physical Plant is the steward of the built environment at Penn State. We are responsible for the design, construction, operation, and maintenance of our facilities. We have over 1,800 staff members in the 11 units that are listed here. When we began our BIM journey 5 years ago, we decided to focus on 2 specific units, although we did analyze the interest level, barriers to entry, technology competence, and advantages for integration of all units. We focused our efforts on the Design and Construction Division, our home unit, and the Work Control Division. Design and Construction is responsible for the design and construction of new buildings, capital renewal, and large major maintenance projects. The Work Control Center, among other duties, plans, prioritizes, and schedules maintenance, repair, and renovation work. The Work Control Center is also responsible for managing the capital renewal program. They develop, prioritize, and program major maintenance and capital renewal projects. It was decided to focus on these 2 divisions since they represent the entire building life cycle. They represent the greatest opportunity for quick success in BIM implementation, and they scored well in our review. We quickly realized the importance of developing a multi-divisional virtual facilities group that included experts in design, construction, and facility operations. The primary duties of this group were to develop processes to acquire, transfer, and access information developed in the design and construction phases. During our interviews with the units within OPP, we realized that there were common themes that resulted from our siloed structure. These included no information is better than bad or difficult to access information, and a distinct lack of confidence in the ability of other groups to follow new protocols related to information. The VFG quickly became the facilitators that kept the information processes intact and functioning. Because of the size of OPP, we were lucky enough to be able to use in-house, retasked staff to perform these duties. We have worked with other universities and owners that have successfully used consultants to perform these duties. However, it is advised that the VFG act independently of the design, construction, and operations groups so they can effectively facilitate and negotiate solutions. After we developed a strategy to implement BIM, we had to establish the process and contracts to procure this from designers and construction managers. We needed to assure that all parties would do the right thing. While an integrated project delivery process was desired, governmental regulations prevented this delivery system. Our task was to develop an integrated approach within a traditional design, bid, build, delivery system. We accomplished this by developing a BIM addendum that was added to both the designers' and construction managers' contracts. This document is the same for both parties and outlines agreed-upon BIM uses. The Virtual Facilities Group is instrumental in working through issues and reaching consensus. We also require the development of a joint BIM plan that is project-specific and agreed to by all parties. Our BIM addendum and contracts refer to our BIM standards and guidelines, a planning template, and an asset attribute list. These documents are regularly reviewed and improved upon by the VFG based on lessons learned from previous projects. It is important to assure proper integration that the project documents, including models and data, be available to all parties at all times. The VFG was able to facilitate this because our contracts establish that the university owns all documents, models, and information generated by all parties to the contracts. The goal of our BIM contract addendum and all related documents is to procure the right information from each party at the right time. An overlap in responsibilities is greatly preferred to a gap. However, we try to make sure that the overlap is minimized by developing an agreed-upon plan to execute BIM on the project. Quite honestly, at the start of our BIM journey, the overlap was relatively large and we accepted that we may be overpaying for the information. However, we viewed the overlap as an assurance that we would get all of the information we needed at the right time and that it would be accessible by all parties. We realized that this overpayment, even though it was small, would help the project teams by covering their perceived risk. As we improved our execution plan, we have significantly reduced this overlap. Additionally, our project teams no longer look at BIM and VDC as a risk, but as a way to accomplish all project goals efficiently. I would now like to introduce Eric Nulty, one of our virtual operations engineers. He will talk about how we developed business cases that showed a positive return on investments.
As BIM developed within the university, we started to analyze exactly how much BIM can save us on our projects. And to do this, we broke it up into 3 different categories. The first is how much BIM can save us in initial design and construction. So these are either our large capital new construction projects or major renovations. The next category we looked at is how much it can save us in redesign and smaller renovations. And the third category is what can BIM do for us in operations and maintenance. And this involves having our technicians go and maintain and operate the building throughout the life cycle. On large design and construction projects, typically over $5 million in cost, owners can find savings from many BIM uses. Some of these BIM uses are owner review, 3D coordination, improved closeout, and 4D modeling. While we were recording savings from all of these uses, we found that taking an active role in owner design review, we could further increase our savings. BIM's 3D tools enable an owner to more efficiently review a project's design in the early stages of the project. This ensures that it meets the owner's needs. Penn State performs 2 types of design reviews. The first is a mechanical review in which we bring in our facility engineers and maintenance technicians to virtually walk through what we consider high-cost maintenance areas. These typically include mechanical rooms, chases, and penthouses. In these reviews, we analyze the design from a maintenance perspective. This often leads to changes in the layout resulting in a more affordable to maintain facility. We also perform an aesthetic review in where we virtually walk our end users through the facility. These end users are often the deans and presidents of the university or other individuals that will occupy the space in the future. A 3D environment here enables the individuals without the ability to read engineering plans to better understand the product that they will be buying and then make changes at an earlier time in the project where the cost will be minimal. To give an example of some of the issues that are identified in these design reviews, here's a penthouse on one of the projects that we're currently building. In this review, we brought in our engineers and maintenance technicians to walk through this penthouse, and they quickly found some things that the initial designers didn't recognize. The first here is the structural steel clearance between the deck and the roof line. While this is plenty to allow for access of an individual, when it comes time to replace fan coil units and other large pieces of equipment, there isn't enough room to actually get the equipment out without modifying the steel. We also discovered that the ductwork didn't provide enough clearance. So by identifying these issues early on, we were able to make changes at little or no cost to the project. By performing these early design reviews, we've realized some significant benefits. The first is that we have improved constructability of the project by reducing change orders during construction. Secondly, we have a facility that is optimized for maintenance and its overall life cycle. And last, we can obtain early owner feedback that again reduces late-term changes in the project. The second area where we saw great benefits from BIM is in design renovation. We performed 3 in-house case studies to get these savings. The first was what we considered a major renovation project that had about $1 million in design fee. The second one was a medium renovation project, and it had approximately $100,000 design fee. And the last was a small renovation project with about a $10,000 design fee. On each of these case studies, we saw benefits from using a BIM as-built model as compared to traditional as-builts. On the major renovation projects, we saw about a 26% savings. On medium renovations, we saw 35%. And on small renovations, we saw 39%. As Ed said, with our $400 million capital renewal plan per year, we're spending about $40 million a year on just design. If we can save 25% of that in design fee, we're saving $10 million a year. The third area where we see great benefits from BIM is in operations and maintenance. Every year, we perform about 164,000 work orders, totaling almost 440,000 man-hours in work. We also found that our technicians waste over an hour a day due to poor information about the work they're supposed to perform. We think with BIM we can save them at least 45 minutes a day by providing them with better information. By saving this 45 minutes, we can save about $2.2 million every year, equaling about 10% of our operations budget by having accurate records of our facilities. Next, I'm going to introduce Craig, where he will talk about the roles of our virtual facilities group.
Thanks, Eric. So the primary role of the virtual facility group, as Ed mentioned previously, is really to be the eyes and ears of the facility managers during the BIM implementation on a project. So we're involved early in the design, throughout construction, and all the way to turnover on these projects. And our focus is what information do we really need to operate and maintain these facilities. It all starts with BIM Execution Planning. Through many iterations, we determined that it's really important to start early with our execution plans. We have a greater influence on the project's goals and decisions, and we found that the costs can be reduced by starting early. It's also important to define the project goals, not only for ourselves as owners, but for the entire project team. They have a lot to bring to the table, and we want to make sure that their BIM implementation is as efficient as ours is. Also, this is a contractually obligation for the project, but we want to make sure that this execution plan is readable. We want everybody to understand their risk so there's no surprises in the end on the project. So through execution planning, we determined that we could actually influence the efficiency and effectiveness of our technicians at the end of the day. We do this through several iterations. One of them is maintenance-friendly coordination. We want to make sure that our maintenance workers have enough room to operate and maintain the equipment, as well as to access any valves and any levers or filters that they might need through their daily activities. This is extremely important, and something we determined and something we put into a rule is any space during the design phase that we define as a facility manager turns into a rule during construction, which means a pipe may cross this area, but it has to be approved by the owner representative, which would be the BIM manager in the case that the facility manager is not available. One of the major benefits we have with BIM execution planning is information into operations and maintenance. We determined that through our Maximo integration, through our asset management system, we could actually leverage the information in BIM in our Revit models and capture this throughout design and construction for use in operation and maintenance. Therefore, we determined different points during the construction phase to implement this information. Through design, we require our design teams to record a lot of the major design intent information. Contractors then validate that design intent information or change it on the submittal process, as well as we hire the commissioning agent to also help validate and record their commissioning information on a majority of the equipment that we operate and maintain. In addition to the information, we also collect geometry on each project using BIM execution planning. This is called the record model development process. It may seem like a pretty simple task. However, it takes several iterations of BIM execution planning meetings to actually come to a conclusion of this process. It all starts with the designer's model, which we call the design intent model. This is where we document the design intent or basis of design information, which is extremely important for facility management. Once that's complete and validated, the contractor then receives that information and converts it to the means and methods model. Then, during construction, the means and methods model is then updated with all design and construction revisions. In addition, the designer is then responsible for updating the design intent model with all construction revisions from the design perspective. Those two models are then turned over, one in terms of an as-built model from the construction means and methods model, which is provided to the designer to form the record model. It does seem a little bit convoluted, so you can understand why it takes several iterations, one with the language, two with the actual process, but once we get it defined, it is extremely beneficial, and we uncover a lot of challenges with the modeling procedure early in the project. By far the biggest responsibility of the virtual facility group is to ensure that the geometry and data that we receive is accurate. No information is better than bad information, as Ed stated before. So to ensure that this information is correct, we developed a model and commissioning process, which you can see on the screen in front of you. We have a few iterations throughout the design and construction process where we can validate both the geometry and data. One of those is through the design process, where we look at the design intent information and ensure that it is correct and accurate. We use the contractor, the commissioning agent, as well as ourselves, the BIM managers, to ensure this. Then in the construction, which we call the midpoint, once the submittals are complete and the information is entered into asset management systems, we the BIM manager, along with the design team and the commission agent, validate the construction information at this point in time. And finally, at turnover phase, when the record model and as-built information is being developed, we want to make sure that it's accurate. So we enlist the design team who was helping us develop the record model anyway, help us can validate this information. We want to ensure that the commissioning information is also imported at this point in time and this information is accurate. So the goal in mind at turnover is that we take that, develop an asset attribute database off the turnover information, which will then be entered into our asset management or our CMMS system. So you can see why it's extremely important to get this information accurate. We want everybody to be pleased with the end result of BIM. So just to give you an idea of what this looks like in model commissioning, we have a quick example here. So through different iterations, we're going to show you the air handling unit, what's going to be added, the design intent information through late design, where we have the equipment information and really at this point in time design intent of how this air handling units should perform through the construction operation phase. Once we move into construction, we now care about more detailed information. We've made the decision on who the manufacturer is going to be through the submittal process, and we're now entering more detailed information at this time about this piece of equipment that is included in the construction documents as well as the submittal phases. And finally, we have the turnover phase. At this point, all the pertinent information should be entered into the model for turnover purposes, including all the commissioning agents' work, the static readings of the equipment, as well as the installation date, warranty date, and now we're looking for barcode information that we can track in terms of our CMMS system. So all this incorporated makes one good delivery to our facility management team. Above and beyond BIM, the Virtual Facility Group has also taken over turnover management. So BIM is a small portion of this, but we also think that it's extremely important to get a handle on all the documents on a project. What you see in front of you is just a list of the information or the documents that are available to an owner on a typical project. We were able to record about 60 document types, which would become overwhelming to think of the information we actually care about or need. So we took a stab at developing forever documents, or the information that we want to keep forever in terms of Office of Physical Plant, archive these for use into facility management. It may look pretty simple, but it was a long, arduous process to even determine what information we wanted in terms of document management, since there are so many opportunities. And finally, it's our responsibility, once all this information is collected and the models are incorporated into facility management, to actually maintain this information. This takes a large responsibility, and we'd be lying if we said we had this understood right now. But we are at least organizing this information correctly in terms that if we do change something, we'll be able to attach it to the model or document information to be able to review for additional facility maintenance or renovations for future use.
Although we have had tremendous success, as Eric and Craig have detailed, we are not resting on our laurels. In implementing BIM at Penn State, we have not fully realized all the possible benefits, and we have several initiatives on the virtual drawing board to help drive additional wins. These include full implementation of the integrated project delivery method. We are currently developing a plan to implement this on our first project, which will be a building renewal. We will keep you posted on our adventures with IPD. Cloud-based collaboration is becoming easier and less expensive. There are many potential risks and rewards associated with this technology. While it brings possible problems with data security, it allows ready access to information for all team members. We believe that developing good processes and close attention to details will help minimize risk and maximize the rewards of better collaboration. The cloud also allows real-time information access by the project team. This will allow greater quality control and the ability to diagnose and correct problems early in the process, thus reducing change orders and associated costs. Better hardware and software, coupled with high-powered handheld devices, has resulted in augmented reality becoming a convenient tool for the facility life cycle. Laser scanning and digital model creation have resulted in the inexpensive and rapid development of digital campus models. The ability to merge GIS and other forms of campus data together to form new virtual campus models will become more prevalent and demanded by users. We anticipate that these models may create a new funding stream for facility owners to develop and manage models that we need for operations. University administration sees these as great tools to sell our campus to visitors, prospective students, and donors. But the real answer to the question of what the future holds is who really knows? I cannot believe the progress that has been made over the last 5 years with BIM and VDC, and I have a hard time predicting the future implementation of information technology on facility management. I may not be able to predict the future, but what I can tell you is how to find more detailed information on what we have accomplished. Our BIM journey was started by collaboration with the academic side of the university. Our architectural engineering department, which graduates outstanding professionals like Eric and Craig, develop the basis for our program. A great source of information is the Planning Guide for Owners and the Project Execution Planning Guide. These two documents, which Eric and Craig help author, were the starting point of our journey. They can be found at the department's website at bim.psu.edu. These two documents can be downloaded and customized for your projects and your wants and needs as a facility owner. Also on this site is a link to OPP's website. Our website provides free access to the work that we have done to customize the department's guides for our facilities. The BIM Addendum, Execution Planning Guide, Asset Attribute List, Information Exchanges, and LODs are available for your use. We invite you to build on our success. Our only request is to please give us any thoughts, comments, or experiences that you may have as you review our documents. Remember, collaboration is the key to success.